Okay, so this is the test to review for stats. I had forgotten to press record yesterday, so I'm just doing it here for us again so that you guys have it. So test 2 is going to have 40 questions and 3 bonus questions. And so one of the bonus is a riddle, and then the other 2 bonus we will see in the review in just a minute. So first question starts out, is it a discrete random variable or a continuous random variable? So remember, discrete, they call these countable values. These are whole numbers. And the secret is that if you see the phrase, the number of, right? The number of is the secret. Continuous is really everything else. And it's considered to be in intervals, right? So like decimals and fractions and things like that. Okay, so I'm just going to use a D or a C as we go through here so that I don't have to write too much. So what I see for A is the number of days. That's going to be discrete because remember, the number of means discrete. Okay, the height of a person, that's continuous because there's all kinds of little intervals where you can grow height-wise. C tells us the number of persons, that's going to be discrete. Okay. The time spent, that's continuous because for time, you've got hours and minutes and seconds and milliseconds and really days and years and all that good stuff. Okay, the price of a house in Vero, that's also continuous because remember, price has cents attached to it. Now, a house price is not going to have cents attached to it, but price in general does. So the takeaway from this is that if it says the number of, it's discrete. Also, sports scores or points in a sporting event, those are discrete. But other than that, everything else should be continuous. Okay. All right, so if we continue down to number 2, it says that it wants the 2 laws of probability. So it's not really worded that way, but that's what they're looking for. So for a discrete random variable x, the probability of any value of x will be between 0 and 1, right? That's that first law of probability. Now on the test, you're going to see it written as a compound inequality. So this is what we're looking for on the test, okay, is that the probability is anywhere between 0 and 1, and it includes 0 and 1. All right, that second law is that the sum of all the probabilities are going to add up to give you 1. And we use that a lot whenever we are summing up our columns. Okay, now this is important. Remember what can and can't be probabilities. So I don't have a question like this on the study guide, but we did one on the packet. And then I know you guys had some in your homework. And remember, they would give you several probabilities and you would have to say what can't be a probability. So remember, according to this little interval here, there are no negatives. You can't have a negative probability, right? And you also can't have anything greater than 1. No negatives are greater than 1. Remember, those cannot be probabilities because, again, they break this little inequality situation. All right, so number 3 could be a lot of different things, but the word that they're looking for is this word that we used up here. What they want you to know is that a discrete random variable has countable values, right? They're whole numbers. You can count them on your fingers. They're not going to be decimals or intervals of any kind. All right, now number 4 wants you to give the 4 conditions necessary for a binomial experiment. All right, well, we listed the 4 criteria for a binomial experiment in chapter 5, but these are a little different. There's one that's a little different. So let's go through. We know that there are n identical trials. We know that. We have to have the same number of an experiment over and over again. We also know that the trials are independent, right? So it doesn't matter what the outcome of the last experiment was. It's not dependent on that. So each one is independent of the others. Okay, another characteristic is that each trial has only two outcomes, right? That's why flipping a coin is such a good example of a binomial experiment, because you only have the option of heads or tails. That's it. Okay, here's the one that's a little different. And so this one, they're actually going to incorporate P and Q into it. So we already talked about the fact that P is the probability of success and Q is the probability of failure. Okay, they also go as far as to tell you that P plus Q equals 1. And we know that because Q is 1 minus P. That's how we find it. So this one is a little new when they talk about the P and the Q. Now on your test, you aren't going to be able to fill in 4 options, and you obviously can't pick more than one option. So on the test, they're going to ask you, which is not a condition? Okay, which is not a condition. So if you have A, B, C, D choices, 3 of those 4 are going to be 3 of these 4. And then one of those options is not a condition. It's going to be something else, probably dealing with I don't even know, to be honest with you, but something kind of crazy. And so that would be the one that you would choose. So they're going to ask you which is not, but these are the 4 that are. Okay. All right, so number 5 is tossing a coin 10 times and observing for a head or a tail, an example of a binomial experiment. Well, I already told you that yes, flipping a coin is always a binomial experiment. It's like the quintessential binomial experiment, okay? All right, so now these directions are a little off. We're going to answer 6 through 11 using this information down here, okay? Oh, I have a key formula sheet under here. Whoops. Okay, move him out of the way. All right, so here we go. All right, we're going to answer 6 through 11 using this. Now notice I have these columns here. These are only if you want to find these answers by hand. And frankly, I think we all decided as a class that we're not really the hand kind of people. So you don't even need to fill those out. All right, so first thing we're going to do, 6 through 9, we're just going to look at these probabilities and decide the answer. 10 and 11 is where we're going to have to put them in our calculator and find 1-bar stats because we need the mean and the standard deviation. Okay. All right, so number 6 wants to know the probability of X being at most 3. At most 3. Okay, well, remember, if that's confusing, think about money. So if somebody needed to borrow money from you and they said, I just need at most $3, would you give them $4? No, you would give them 3 maximum and maybe less, right? So at most 3 is going to be 0, 1, 2, and 3. This would be at most 3. Let me erase this 6 through 11 here so you don't get confused. That just told us that we were going to be using these. Okay. All right. So at most 3 is 0, 1, 2, 3. So we're going to take these 4 probabilities and we're just going to add them together. And when we do that in our calculator, we should come up with 0.57. And there's our answer. Okay. Number 7 wants the probability that X is exactly 5. Well, that's easy. We just go to 5 and here's our probability. It's 0.17. Those are my favorite. Okay. Number 8 wants the probability that X is at least 4. At least 4. So if you need to borrow at least $4, you need $4 or more, right? So 4, 5, 6, 7 is going to be at least 4. Notice we included 4 there. Notice we included 3 for the at most. Okay, so if I add up 0.14 plus 0.17 plus 0.09 plus 0.03, I come up with 0.43. All right. Now, number 9, the probability that X is more than 5. Most students do really well with that. That's pretty straightforward. Just remember, more than 5 does not include 5. So more than 5 is simply going to be the 6 and the 7 probabilities. So we're going to have 0.09 plus 0.03 there. And that's going to give you 0.12. Okay. All right. Now we're going to find the mean. Okay, remember that's mu. And we're going to find the standard deviation. And remember, for a discrete random variable, sigma is our only choice. That's what we're going to find. Okay, so we're going to go to our calculator now. Whoops. Let's see if you can see this. That might be a little better like that. Okay, so what I'm going to do is I'm going to put all the x's in L1 and I'm going to put all the probabilities in L2. Okay, so here's my calculator. I'm going to go to Stat, Edit. Now I already have things in my list. Oh, I might have them in from yesterday. I think I do. How about that? Okay, so I put in L1 0 through 7. L2, I have in all the corresponding probabilities, so they're already in there. And then I'm going to quit. Then I'm going to do Stat, and I'm going to scoot over to Calc, and I'm going to do 1var stats. Okay, L1 is first for the list. L2 is second for the frequency list. Now, if you have the version that you actually need to write it in, then remember what you're going to do is once you put in 1var stats, I put 1var starts. Okay, 1var stats. Then you're going to hit L1, comma L2, and then hit enter. Okay, this is for the oldie but goodie. Okay, all right. So here's the fancier one, right? Now, notice your calculator is never going to say mu. It's always going to say X bar, but that's okay. That's our mean. So 3.35 is the mean. Okay, now we want the standard deviation, and here it is, 1.72. Okay, we'll stop right there. Notice it didn't ask for the variance. You very rarely will be asked. I don't know that you are asked again the rest of the class, to be honest with you. I think that you're just asked for the standard deviation from here on out. So that would be it, and you're done. Okay. All right, notice that we did not use any kind of binomial situation here because it never said the B word. It never said binomial. And so we just simply used discrete probabilities. That's it. We just used what we knew, the 1var stats information. All right, now we're going to get into some binomial probabilities. All right, how do I know we're getting into binomial probabilities? It's going to tell us. It tells us for 12 through 16, we're using binomial. So we can either use our binomial table, which I'm going to use if at all possible because I think it's easier, or we can use our calculator if we come up with something that we can't use on the table. And what we're going to find out is there's one problem that's going to have that issue. Okay, so let's read number 12. We expect binomial, so let's see what happens. Okay, 10%. Well, we know 10% actually looks like this, but we also know anytime we have a percent and we're dealing with binomial, this is our P. It's 0.10. Okay, we just change it to a decimal, divide by 100. Of all college graduates hired by companies, stay with the same company for more than 5 years. Now, a lot of students want to do something with this 5. This is just describing the problem. So don't let that confuse you. You're going to have the same wording on the test. I just want you to see it and then forget it. They're just describing what the 10% is referring to. Okay, we're definitely using binomial. Find the probability that in a random sample of 12, okay, that's going to be our N. That's our sample size. Of 12 such college graduates hired recently by companies, exactly 2, that's going to be our X. We'll stay with the same company for more than 5 years. Again, that's just describing the situation. Okay, so now I can put this in my calculator, Or I think it's easier just to use the table, but I identified the P, identified the N, and then in this case, I just need exactly 2, so my X is only 2. I'm just looking for one particular value. Okay, so here's my table. N is 12, so I have to find where N is 12. It's actually going to be on the next page. Okay, here we go. This is left over from what we did in class yesterday. Here's N is 12. All right, then X equals 2. So I don't need the whole N is 12 situation. By the way, 10, 11, and 12 are on the next page. I just need the X is 2 situation. That's it. I just need this line. Now, P is 0.1. Okay, I don't have the P's listed on every page, but if you go back to the front, you'll see the first column is 0.05. The second column is 0.1. So this is the column that I want. So it's this column in this row. This will be the value that I'm looking for. This 0.2301 is what I'm looking for. Okay, so 12 was my N. Here's my 2 for X, and this is the column. Okay, so 0.2301, and there's my answer. All right. Okay, let's look at 13. 13 says, suppose 60% of all children in a school do not have cavities. All right, well, this is our P, because we know anytime we see that percent, we're going to change it to a decimal. There's our P. From the binomial probability, so that's how we know it's binomial, distribution table or your calculator, what's the probability that in a random sample of 9, there's our N, selected from this school, at least 6 will not have cavities, at least 6. So now we have to think about this. Our X's for an N equals 9 are going to range from 0 to 9. At least 6 means 6 or more. So we're talking about a situation where X is 6, 7, 8, and 9. I know it ends at 9 because that's our total here. Okay, so here we go. Let's go back to our chart. In this case, we're looking for N is 9. Here it is. Here's N is 9. Here's all our possible X's, 0 through 9. Okay, we said we want the X's for 6, 7, 8, and 9. So this is what we're looking at. We're looking at this chunk of information, these rows. All right, now we just need the right columns. Okay, well, first column is 0.05. Remember that that's just from this first page. If you turn it over, it's got your P's listed. 0.1, 0.2, 0.3, all the way over here's 0.6. This is the column that we want for our P. So this is the little piece of information that we want to find. This is for 0.6 and 9, where X is 6, 7, 8, and 9. So we're going to take these 4 values and we're going to add them together. And I'm just going to put all 4 of those in the calculator and sum them up. And that's going to be my answer. So when I add all those up, I get 0.4826. And that's my answer. So make sure that you add all 4 of those. Okay, so now 14 doesn't actually want you to find a probability. It just wants you to fill in some information. So this says that according to a poll, 49% of Americans, well, we can stop right there. That's going to be our P, 0.49. 49% of Americans say that the winter holiday season is the most stressful time of year. Suppose you survey 12 Americans. This is your sample size. This is your N in this binomial experiment. And then that's all they give us. Okay, well, the only other thing they want us to fill in is Q, but they don't give us Q. So you need to remember that Q is 1 minus P. If you need to write this on your formula sheet, your key formula sheet, please do that for the test because this is not on there. So we want to make sure that you don't have some kind of brain lapse and just forget that little guy. So Q is going to be 1 minus P, so 1 minus 0.49, and Q is 0.51. There we go. All right, now 15 wants you to use this information we just found up here in 14. Find the mean and the standard deviation. Okay, you cannot put a binomial distribution into one bar stats. So this is where your key formula sheet comes in. Now I'm going to give you one of these on the test, and I'm also going to give you the binomial tables. But if you want to use your own because you have marked on it, that's fine with me. Okay, if we flip over, we come up with chapter 5, okay? And then if we come down right here, binomial oh, that's not it. We don't need that formula. Sorry, guys. Right below it. Right below it. Okay, right below binomial probability formula, we see the formula for the mean and we see the formula for the standard deviation. Okay, so make sure you can find these on your formula sheet or you've highlighted them or done something. But the mean is n times p and the standard deviation is the square root of n times p times q. Okay. All right, so the mean is n times p. So I'm just going to do 12 times 0.49, and I get 5.88. My standard deviation is the square root of n times p times q. Okay, so we don't need the variance. If you're a little concerned about him in the calculator, let's just make sure that we can put him in the calculator, okay? So we're going to take the square root of, okay, n times p times q. And you should get 1.73, okay? There we go. All right. Now let's try 16. This is our last binomial distribution problem. Okay, 35% of all law students who sit for a bar examination pass it for the first time. Okay, so that is going to be our P. Our P is 0.35. Using a binomial probability distribution, so we know binomial, what's the probability that in a random sample of 14, that's our sample size, at most 3 will pass it for the first time? Okay, so now we have to remember what in the world did at most mean? Well, remember, if I need at most $3, I'm not going to need more than that. I'm not going to need $4. So that means 3 and less. Okay, here's where it's tricky. I need 3 and less. So I need 0, 1, 2, and 3. Because remember, for binomial, for a discrete distribution and for binomial distribution, the possible x's are 0 to n. So don't forget that you're going to have to include 0 in there. That's 4 different numbers you're going to have to add up. There will be an option if you only add up 1, 2, and 3. You're going to see that on there. So make sure you add up 0, 1, 2, and 3. Okay, so I'm going to make a little chart just so that I don't mess up and that I put all my numbers on here. Okay, this is that question that I mentioned before where there's going to be one where you have to use binom PDF in your calculator. How do I know it's this one? Well, look at your P. Your P is 0.35. When you go to your chart, that's not an option. If you notice, other than the first and the last, they don't end in 5. These are whole, like 0.1, 0.2, 0.3, 0.4, all the way across. So I don't have a 0.35. So if you don't have that column available, you can't use the chart. So on your test, you're going to have one problem like this where your P is not on that chart. And that means you have to go to your calculator. Okay, so let's make sure we remember how to do that. We're going to go to distribution. So second bars, and then we have a lot of choices. We're going to go down. Remember, there's 2 binomes here. We want PDF. If you're not sure, if you're going to forget which one, write that on your formula sheet. Write binom PDF up at the top so you don't forget that's the one you're looking for. Okay. All right, so if you have the newer one, your N is 14, that's your trials. Your P is 0.35, and then you're going to have to do this 1, 2, 3, 4 times. You're going to start with x equals 0. So that's already been put in for me here. And then I'm going to hit enter. Now, if you have the older one, this is where you're going to start. You're going to have N, comma P, comma X. So make sure that you put them in that order. If you switch up the order, it's going to mess up. N, comma P, comma X. We have to start with x equals 0. And I get 0.0024. So I'm going to come over here. This is why I made this little chart. And that's my 0. Okay. Now I have to do it for x equals 1. So I'm going to go back, Binomial PDF, 14 and 0.35 don't change, but I have to put in a different x value. And this time I'm going to put in 1. There we go. That value is 0.0181. Okay, now I'm going to do it again, and I'm going to do it for 2. Now, if you have the ability to go back up and highlight this, you can do that and then come over here and just change the X. That's so much simpler. Some of you don't have that option, and you have to keep going back to Binomial PDF. So if you have the ability to do that, just keep doing that. And then your very last one would be to change your X to 3. And then you get 0.1366. So the key here is to remember you have to do it 4 times. Then once you have all 4, you're going to add them all up, and that's going to be your answer. So when I add all these up, I get 0.2205. And there we go. And that's my answer. So that's all the binomial that you have to do. You're going to have most that you can do right on your chart, but you're going to have one that has a strange P that you're going to have to do on your calculator. Okay, number 17, name and describe the 3 conceptual approaches to probability. This is a bonus. Okay, this is a bonus. All right, so the 3 approaches are classical, relative frequency, and subjective. All right, so we named them all. Now we need to describe them. Now it doesn't have to be a paragraph or anything, just give me a little snippet of information. So classical would be equally likely outcomes. That would be just fine, okay? Relative frequency, you could say practice makes perfect. Remember, this is the law of large numbers. This says that the more you do something, the more you approach perfection or a probability of 1. Or you could put that this is experimental based. That's the same thing. Probabilities change depending on how many times you do the experiment. So either practice makes perfect or experimental based. And then last but not least, subjective means based on hunches or beliefs, or you have a feeling, something like that would get you full credit, okay, get you bonus. All right, 18 wants to know, okay, if events A and B are independent, meaning they have no bearing on each other, okay, then the conditional probability of event A occurring given event B has already occurred is just the probability of event A. This means they're independent because we don't care that event B has occurred. It really doesn't matter. It's still probability of event A occurring is going to be the same regardless of whether B happened or not. So that's the definition of independent. All right. So number 19 actually wants you to put that into words. And so what they're going to give you is the sentence that, and I might have spelled these wrong, the occurrence of one event does not affect the probability of the occurrence of the other event. Okay, so the occurrence of one event does not affect the probability of the occurrence of the other event. It really doesn't matter. These two are saying the same thing. Okay, mutually exclusive events, what are those? They are events that cannot happen at the same time. They cannot happen at the same time. So some examples of that are going to be yes and no, and also male, female. Those events do not matter. Yeah. I'm doing class. I'm sorry. Okay. All right. Sorry. We had a little interruption. We're good. Okay. So events that cannot happen at the same time. So there's two examples. One is yes and no. They can't happen at the same time. The other one is male and female. They can't happen at the same time. Okay. So another situation, mutually exclusive, those are dependent events. Okay, so they are dependent. Now this confuses some students because they want them to be independent. Well, in order to be independent, you have to not care at all about the other event. But mutually exclusive events are dependent because we have to know what they both are so that we can say, oh yeah, they can't happen at the same time, right? So we have to be aware of them. We have to know what they are. We have to know the probability of each. So they are dependent, even though that kind of goes against your gut feeling sometimes, but they're dependent on each other so that we can say, oh no, they can't happen at the same time. Okay. All right, well, that brings us to the next page. So these are the rest of the probabilities that we were talking about. So these are marginal probabilities and conditional probabilities here. So let's see if we can get through these. We've got unions and joints and all that good stuff. All right. So we have a little table, and this is all about if a student suffers from math anxiety. Okay, so does math give them hives? Does it make them nervous? All right, well, we need to fill in our totals. So that's super important. So if I add up the males, I get 240. And if I add up the females, I get 260. Then if I add these up as a total, I get 500. And that makes sense because this told me that I should have 500. Okay, now if I add up the yeses, I get 335. And if I add up the no's, I get 165. And then it's always a good idea to make sure those totals also total to 500. And they do, so we're good. All right, so let's jump right in. This asks you if you randomly select one student from these 500, the probability that this selected student is female is what? Okay, well, they're only asking you for one thing. They're just asking you the probability that the student is female. So if it's just one item they want or mention, your denominator is the grand total and your numerator is the total of females. And then you know statistics likes decimals. So there we go. And by the way, if you wanted to see what this looked like written like this would be the same thing as this sentence, would be just find the probability of your student being a female. Okay, let's look at number 23. So again, we're just choosing one student and we want the probability that this student suffers from math anxiety. So this would be the probability that they said yes. Okay, the probability they said yes. Okay, so we're only asking for one thing. So again, we have 500 as the whole denominator. And then we want to total the yeses, which is 335. That ends up being 0.670. That's our answer. Okay, now the next two have this bold underlined word, this given. So this is going to be a different situation. Our denominator is not going to be 500. So let's read and see what we have. Okay, so we're going to select one student from the 500. We want the probability that this student suffers from math anxiety, so that's a yes, given, remember that's that line, he is a male. All right, that's what we're looking for. Now, your denominator, because we're looking at two items and we have the G word, your denominator is what comes after the given. So the denominator is over here. It's what comes after the given, okay? So my total males is 240. That's my denominator. Then I go into the two numbers that make up the 240. These two added together to give me 240. One of these is going to be my numerator. And so it turns out I want the numerator that says, yes, I suffer from math anxiety. And then I put it as a decimal. I get 0.763. And there's my answer. Okay. All right, let's try another one. Okay. So I see the given again. So I want the probability that the student is female given she does not suffer. So that's a no. All right. So this is going to be my denominator, remember, because it's after the given. It's what comes after that. So I total the no's and I get 165. My numerator is going to be whatever number makes up the 165 that satisfies this condition. So I have a 57 and a 108. That's the number of males and the number of females. I want female, so my numerator is 108. And then my answer is 0.655. That's my answer. Okay, so this is marginal. We just hung around the edges, the margins. These are conditional. Our total our denominator is what's to the right of the given, and then we went inside to figure out the numerator. Okay, number 26. Which of the two following pairs of events are mutually exclusive? This means which two pairs of events cannot occur at the same time. Okay, well, it's going to be A and it's going to be F. Okay, those cannot occur at the same time. So those are mutually exclusive. All right, let's look at 27 and 28. These are our last two probabilities. We still have to use that chart up top, but let's just set them up first. Okay, so 27, the probability that a selected student suffers from math anxiety or that he is a male. Okay, this is a union situation. Okay, with a union, you're going to have a fraction plus a fraction minus a fraction anytime you see or. Okay, your denominator for all three is going to be the grand total. Then your numerator is just going to be each piece of these. So this first numerator is going to be a student that suffers from math anxiety. So it's going to be the yeses. So if I pull my paper down, okay, the total yeses, looking at this column here, total yeses is 335. Okay. Then it says, or he is a male. Okay, so now the numerator for the next one is going to be the total males, which is 240. Okay, now notice when I used this column in this row, this one particular number was counted twice. That's the one you're subtracting out. The one you're subtracting out applies to both the yes and the male. So the yes and the male is what is going to come out. And so that is going to be your answer. Now, you can put each one of these in the calculator, or we said that a little shortcut is just do the numerators. You can do 335 plus 240 minus 183. Hit enter, then divide that total by 500, and you should get 0.784. Okay, so that's a union. Now, your next question wants the joint probability. Okay, this is joint probability. We see the word and. That's what joint probability means. This means you're only going to have one fraction, okay? Because we're going to do it that little shortcut way, one fraction. You're going to have the grand total on the bottom, and then you're going to have the numerator of exactly whatever this is describing. So this wants a student that does not suffer, so we want a no, and that is female, and we want a female. So if I go female, no, that 108 describes both of those criteria, and that's going to be 0.216, and there's your answer. Okay, so notice these guys all had the grand total of 500 in the bottom. The marginals had the grand total of 500 in the bottom. The only ones that didn't were the givens, the conditionals. They had a denominator of whatever's to the right of given. Okay. All right, so now let's do some calculator work. So now we want some factorials. Okay, so 29 wants us to find the value of, okay, let's see if I can move this a little better. Okay, parentheses. Now I can do 6 minus 0, or I can just put the whole thing in my calculator. But I do want a factorial. So remember, that's math, scooch, scooch, scooch to probability. And we're going to come down here to the exclamation point. That's your factorial. We hit enter, and we get 720. That's our answer. Okay, number 30 is 0 factorial. Now, a lot of you already know the answer to that, but if you're not sure, put it in your calculator. We'll put in 0, math, scooch, 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 exclamation point, and my answer is 1. And there we go. Okay, so make sure you can do your factorials. All right, last page. Okay, let's look at 31. Okay, 31, the probability that a family owns a dog is 0.73. What's the probability of the complementary event? So the complementary event is like the opposite event. What they're asking you for is, what's the probability that a family does not own a dog? Well, you either do or you don't. So to find this, you're going to do 1 minus 0.73. And that's going to end up giving you 0.27. And that's your answer. So that's what they're looking for there. Is just 1 minus whatever they give you. Okay. All right. So complementary events include all outcomes for an experiment. Okay. So that's what the definition of that situation is. All right. 33. If you roll a die one time, what's the probability of getting an even number? Okay, well, this is just good old-fashioned probability. So our denominator are how many possible choices we have. So on one die, how many possible numbers could we get? Well, we could get 6, right? There's 6 sides, 1 through 6 on a die. Okay, what would be a good outcome for us? How many numbers would give us an even number on a die? It's actually going to be 3 because of the numbers 1 through 6. 2 would work, 4 would work, and 6 would work. So put that in your calculator, and there you go, 0.50. Okay. All right, now 34 is that counting rule that we saw, where we talked about how many appetizers or entrees or drinks you could have, and then we just multiplied the numbers together. So this says if you roll a die 4 times, what are the total number of outcomes? Well, there's 6 possible outcomes. So if we multiply 6 together 4 times, there are 1,296 possible outcomes. All right, 35. The numerical measure of the likelihood that a specific event will occur, that's actually the definition of probability. Okay. All right, let's look at 36 and 37. 37 is a bonus. All right, 36 is a combination. It says you randomly select 4 crayons from a box of 12. So this is a combination. You always put the biggest number first and then the smallest. So depending on which calculator you have, you may need to go ahead and put in that bigger number. Then we want to do math, scooch, scooch, scooch. NCR is right above your factorial. And then we'll put in the smaller number. And we learn there's 495 combinations. Okay. All right, now number 37 says permutations because the order of selection is important. So now we're going to have NPR, bigger number first. So I'm going to put in 7. I'm going to go back to math, scooch, scooch, scooch. There's NPR, throw in a 4, and we get 840. Okay. All right, last 2. Okay, so 38 says, probability that a student at a university is female is this number, that a student is a math major is this number, and that a student is both is this number. Then it wants the probability that the student is female or a math major. Remember, when you see or, it's a union. And you normally have a fraction plus a fraction minus a fraction. But in this case, they've already given us the fractions as decimals. So you're just going to take them right in the order they give you. You're going to take the probability they're female, add it to the probability they're a math major, and subtract out the both because this is the both. And when you do that in your calculator, you should get 0.788. There you go. All right, now we're going to do one that is joint, okay? Joint and probability. This tells you the probability that an adult has a car is 0.85. A researcher selects 2 adults at random. So we're going to have 2 numbers we're going to multiply together. It wants the probability that the first adult has a car. Well, that's 0.85. Then it wants the second adult does not. Okay, we don't have that probability, but it's just like this situation up here with the dog. You either have a car or you don't. So to find this probability, we're going to do 1 minus 0.85, and we're going to get 0.15, and we're going to multiply them together, and your answer is 0.128. Now, this just tells you that this is the formula, so don't worry about this guy here, okay? But that is the end of your review. So that will prepare you. That'll get you 100 tomorrow on the test, and I will see you then. Bye-bye.